All right, I'm going to go over the 2007 FRQ number 3. So it tells you that an external direct current power supply is connected to 2 platinum electrodes immersed in the beaker containing 1 molar copper sulfate. As the cell operates, copper metal is deposited, right? So copper is being reduced and oxygen is being produced. The 2 reduction half reactions are shown below. Okay, so you've got those 2 half reactions. Keep in mind, since oxygen is being produced, the first reaction, I actually need to flip that because it's liquid water being oxidized. So then when it asks for the direction of the electrons, keep in mind copper is going to be gaining the electrons. Therefore, the arrow you should draw is towards the left, since copper is going to pick up the electrons and water is giving up the electrons. So it's going to move to the left. Write the balanced net ionic equation. Okay, so when I go back, notice I've got 4 electrons and 2 electrons, so I've got to multiply my copper half reaction by 2, and then I add them together. So you end up getting 2 waters plus 2 copper ions gives you 4 hydrogen ions plus 2 copper and an oxygen. So you got 1 point for the correct products and 1 point for making sure it was balanced. Predict the algebraic sign of delta G. Okay, well, since your cell potential, when you add them together, is going to be negative because it's negative 1.23 plus 0.34, your delta G is going to be positive. Okay, justify your prediction. So you can either say because the cell potential is negative, delta G will be positive, or you could say that because it's not spontaneous, because it's requiring a power source. Okay, so you got 1 point for saying that delta G is greater than 0. And you need to make sure to explain the correct explanation. All right, for the next problem, I asked you to calculate your delta G. So you actually can calculate your cell potential. It's negative 0.89 volts. Then you're going to plug that into delta G equals negative NFE. You have 4 electrons, remember, because you multiplied the copper by 2, so it's a total of 4 electrons. Faraday's constant is 96,485, and then your cell potential is negative 0.89 joules per coulomb. So keep in mind this is going to give you joules per mole, not kilojoules, so you're in joules. So if you want to be in kilojoules, you have to divide by 1,000. You don't have to. You can put 340,000 as your answer. So either joules, kilojoules, or joules per mole or kilojoules per mole. So you got 1 point for the correct cell potential and 1 point for the correct delta G based on your answer for cell potential. For E, it says an electric current of 1.50 amps passes through the cell for 40 minutes. Okay, so I need to convert 40 minutes to seconds, so I multiply that by 60. And then I'm going to multiply it by amps, and that'll give me my current, that'll give me the number of coulombs. Okay, now I'm in coulombs. I would just keep going. They separated it out, but I'm going to divide by Faraday's constant to get into moles of electrons. I know that for every 1 mole of copper, I have 2 moles of electrons, and then you can just multiply by 63.55, so the answer you get is 1.19 grams. So you got 1 point for the correct number of coulombs. If you didn't stop there and kept going, that's fine as long as you show the correct work. And you get 1 point for the correct mass. Or if you just show it all together, you get 2 points together. For F, it says calculate the dry volume in liters measured at 25 degrees Celsius and 1.16 atmospheres of the oxygen that is produced. Well, since I know I have 1.19 grams of copper, I'm going to convert that into moles of oxygen. Okay, you use your mole to mole ratio. And then you're going to use Pivnert. And then you can calculate it, you get 0.197 liters. So you get 1 point for the correct number of moles of oxygen and 1 point for using Pivnert correctly and getting the volume.